Hello. Hopefully you all can see me. My name is Joe, and welcome to TGI Kubernetes. This is the first installment of hopefully we'll be doing it every week type of thing where I sit around and play with Kubernetes, and folks ask questions and we sort of see where things take us and we have some fun. So first things first. Let's see. I don't know. Are folks actually watching? This is my first time doing a live stream with YouTube, so I'm figuring this stuff out. Let's see. It says we're live and it's actually happening. But if you all can use the YouTube live chat there, if you want to send some questions my way, that's great. You can also hit me up on Twitter and we can go from there. And I don't know if anybody's actually watching right now. So I guess we can go ahead and get started. So I have a couple of windows off screen here that we're going to use so that I can actually sort of watch for interesting stuff that's going on. If you guys have questions, shout them out. And I'm really hoping that we can kind of make this a little bit of an interactive thing. I think that'd be a lot of fun. All right, so let me check one more thing here just to see. Oh, yep, I am broadcasting, so there we go. Okay. Oh, look, yeah, okay, you guys can see me. Like, seriously, I'm trying to figure this out. So, yeah. All right, so here's my plan, and I figure I have a... Okay, yeah, it says if you were waiting, you might have to refresh to see the video. So, I'm going to post to Twitter right now. This is off screen here. And let's see, let me retweet here. And I'm going to do quote, and I'm going to say broadcasting live now. Tune in and ask questions. Let's have some fun. All right. So cool. All right, so here's my plan. Here's what I was thinking. And if all y'all have suggestions on what you want to go into, what you want to ask about, let me know. I was going to bring up a Kubernetes cluster. I was going to go through a little bit of a demo script that I put together for this fun event here in Seattle called Coffee Ops. It's kind of like a meetup, but they do it in the morning for early risers versus people who like to stay out at night. There's a lot less beer at Coffee Ops. And so that was a really fun event. I went through sort of an interactive demo there, and I thought, hey, it'd be great to actually have other folks see this. And so we figured we'd do that. And so this is a little bit of Kubernetes 101. The next thing that I wanted to do is we can go through the Kubernetes 1.7 release notes together. And I haven't actually read through them all, so I know a lot of the stuff that went into 1.7. I know a lot of the stuff that's kind of been in flight. And so we can go ahead and look at that together, and we can talk about sort of where things are going, what is actually in the 1.7 release. It was released today, which is super duper exciting. A lot of hard work from a lot of people all went into that. And so we can go through the release notes there. And then there were some questions on Twitter about sort of like doing a little bit more of a deep dive on networking and how the Kubernetes networking model works. And so if we have time, we can go ahead and do that. Now, if you think I'm going off in a tangent, if you think things don't make sense, just yell at me, let me know, either in the live chat with YouTube or via Twitter at, just include me at Joe Beda, and we'll go ahead and get started. So the first thing we're going to do is we're going to create a Kubernetes cluster. And let me go ahead and get this started. So we're going to do it on AWS because a lot of folks have access to AWS. So one of the first things that we did when we started Heptio is we had this opportunity to put together a really super simple sort of thing with the solutions folks at Amazon to make it easy to launch a Kubernetes cluster. And so when you do this, it essentially launches a CloudFormation stack. Oh man, it logged me out. Okay, let me take this window. Oh wait, no, this is the wrong window. Oh, okay, there we go. Okay. So I'm not logged in on that one, but I am. There we go. Okay, so Kubernetes quick start AWS. Okay, so this window I'm logged in. So I'm just going to do this one for the Amazon stuff because I'm logged in. And there we go. Okay, this is what you expect to see. So this is going to launch a CloudFormation stack. and it's going to bring up a cluster, and we'll call the stack name live. And so now in production, you're going to want to actually have some sort of multi-zone approach for Kubernetes. This particular stack is very simple, and so it's a single zone type of stack. When you start thinking about multi-zone, and we can make this a whole topic that I can go into some detail and we can talk about, a really viable option is to actually have a Kubernetes cluster per zone, or there's support for essentially having a Kubernetes span across zones, right? So there's pluses and minuses and trade-offs for each of those. This particular quick start right now is a single zone. I'm going to say anybody from the world can log into it. It's actually not as scary as it sounds. And then, oh man, I forgot to add I just created this account and I forgot to add a key pair. So let me go ahead and don't look here. Let's see. And I'm going to do that real quick. I apologize. So if you've ever done this, what I'm going to do is get my key pair, my public key. Yeah, actually, y'all can see my public key. You can actually get it from GitHub if you're down with that. So there's my public key. And then I'm going to, yeah, you can tell that we're doing this live. Console, we're going to do the console here. And EC2. So I just created this Amazon account really fresh. So key pairs, import key pair name Joe Beda laptop, the public key pair there, import it. Oh, it doesn't like it. Public, why doesn't it like it? Does Amazon not like elliptical curve keys? It's not a valid open SSH public key format, but it is. Does it not like the at there? All right, let's try my RSA key. Got to make sure I cat the right one, right? Because that's bad news on a live. All right, so there we go. Okay. Well, now we just learned that Amazon does not like elliptic curve SSH keys. That was surprising. All right, so here we go. This thing is, let's go ahead and reload this. Actually, let me get this window straight. There we go. Okay. Well, now what happened? There we go. Okay. So next, sorry, we're going to call this live. The availability zone 0.0.0.0/0 SSH key. Oh, look, there it is. We're using networking with Calico. We're going to let's do 3 nodes, and that's enough to get us running. There's a whole bunch of stuff that I'm just going to click through, and then I'm going to do create. And so this is going to go ahead and create a Kubernetes cluster. So, and it's going to have a master node and 3 worker nodes. And so that's going to be good enough to get us up and running. Now this takes a little while because what this does is it creates 2 VPCs. Actually, if we go back to the AWS Kubernetes quick start, if we look here, there's a diagram that we can go through. So this is creating 2 VPCs. So there's a public subnet and a private subnet. And then we have a bastion host and we have a load balancer that actually tunnels through to the, okay, so I'm sorry, I'm looking at that. So Ruben was saying that you can tune the stream to HD, and that should actually help if you have the bandwidth to be able to see this stuff. I'll try and keep the typefaces big enough so that everybody can read. So we have a load balancer here that'll actually go through the Kubernetes master, and then there's going to be an auto-scaling group for all of the workers. And it has to set those up along with all the AWS permissions and all sorts of other things that are going on there. And then there's, obviously the internet gateway here. So when all this stuff is said and done, we're going to be controlling this Kubernetes cluster from a command line called kubectl, kubectl. A lot of folks like to pronounce it kubectl. It's a very controversial thing. Whether it's kubectl, kubectl, I think other people have said, which I think is a joke. But anyway, so you have that running on your laptop. or your workstation or what have you, and that'll actually go through an ELB to this master, and then that master will go ahead and control the cluster. And so we're going to bring up a real cluster in Amazon. Once you get these things up and running, they're going to keep running, right? So, you know, you don't have to necessarily go through this relatively slow step each time. But we'll go ahead and look at this so you can see the resources that we're creating here is a whole bunch of stuff, the NAT gateway, and then it's going to go through and it's actually going to create a substack. So we've actually built the CloudFormation stack such that the Kubernetes cluster itself can be run if you already have all the VPCs all set up for you. And so here's that inner stack, and you can see that it's doing things like creating the IAM roles, and that takes quite a while. So we're just going to have to go ahead and be patient while that stuff works. So yeah, let me talk a little bit. If you all have questions, oh, here we go. So Chuck has a gigabit connection. Yes, we know Chuck, and he's bragging so that everybody else knows that he has one. And then Giovanni says, hey, Joe, how would you rank CloudFormation versus KOP for setting up a Kubernetes cluster in AWS? We're currently testing KOPs because of Terraform. Not sure where we'll go. You know, this is a really good question. You know, I know a lot of the folks working on KOPs. We built this quick start as a way to really get started quickly using tools that folks are really familiar with. And so most of our advice right now is to use this quick start for the type of thing that we're doing now, where you just want to get something up and running that you can play with and you can understand how to use Kubernetes before you spend all your time learning how to administer Kubernetes. Once you get to the point where you're like, hey, I think I might want to use this in production, then I think you may want to take the time to invest into using KOPs. It's not that KOPs is hard. It's just that there's a lot more bells and whistles. There's a lot more tunables. There's a lot more to learn in terms of bringing up something that's more appropriate for production. Now, there are, from you know, this stuff is all a moving target. There are some things in KOPs that are in some ways less secure than something like the quick start. But then there's other things that are built for more reliability. Like, for instance, KOPs by default brings up it makes it super easy to bring up an HA cluster, a high availability cluster. That's a pretty fiddly thing to do right now. It's a lot harder than it should be to bring up an HA cluster. So KOPs really makes it easy to go ahead and do that stuff. But when we were building out the tool that the Quick Start uses under the covers, which is this thing called kubeadm, we really wanted to really make it easy to actually build what we thought was going to be the right way to build a secure cluster moving forward. And so one of the things that happens with kubeadm is that each individual node has its own cryptographic identity with how it actually communicates with the server. And so as you stitch these things together, it really makes it easy over time for us to take advantage of some new features, some new stuff that actually just launched in 1.7, to really isolate the amount of information that each node in your cluster has access to. So it's the minimal amount. Now, over time, those types of things will be added to KOPs, no doubt about it. And KOPs is working on using some of the tool set and some of the sort of base stuff that goes into kubeadm. We build kubeadmin to be a sort of like a toolbox that you could use for doing this stuff. So if you were going to build out a cluster for production today on Kubernetes, I would say, you know, you either have to dig deep and really understand a lot of the ins and outs, or if you want something that's a little bit more turnkey, KOPs is a good solution. And there's also the Tectonic installer from CoreOS, which is also pretty easy to get started with and works well with Amazon. Okay, so Chuck's asking, could you go over why the Quick Start creates an ELB that maps directly to the master? Why would you expect to go? What would you expect to go across this load balancer? So when we were building this thing out, the naive way to build this, and I think it's probably appropriate, is to actually have the entire cluster sitting in a public subnet. But a lot of the best practices with Amazon, and we knew that people were going to take this CloudFormation template and sort of grow it and reuse it and sort of like move it in a bunch of different directions. And so we wanted to do what we could to sort of set the right patterns from the get-go. And so best practices in Amazon is to actually have a public subnet with a bastion with a private subnet behind it. And so we wanted to follow that. But now you still want to be able to actually get to your Kubernetes master in a in a way that makes sense, so that you can control your cluster from the outside. And so that's why we created that ELB that goes to the Kubernetes master. It's very targeted. Right now it's just going to that single host. So in reality, it's more of sort of a punch through to that particular host. But it is a way to essentially have this thing work in a componentized way where we can run it in this private subnet, but give very limited access to the rest of the world. All right, let's see where our stack is. It's still create in progress. Let me go ahead and refresh it. You can see that I'm starting to unwind after a hard week with my high quality beer. This is the PBR of Seattle, and it's brewed in Irwindale. So you know it's got to be good when it's brewed in California. I actually spilled some on my laptop. Oh, uh-oh. All right, let's see where we're going here. Create in progress still. So usually it takes a little bit. I think the thing that really ends up being the long pull with these things are some of the IAM roles. It just, for whatever reason at Amazon, it takes a while for IAM to actually come up. So we're actually launching the node group right now, so we're waiting for those to actually come up. All right, so yeah, so in a production setting, when you're really building large clusters, so a lot of times, okay, so let me go into a little bit of a sidebar here. A lot of times when we're talking about Kubernetes, we talk about the master, right? And the reality is that there is no such thing in Kubernetes called the master. There are a set of components that make up the control plane. That's a sort of microservice-ish type of application itself that's fundamentally distributed. In a lot of very simple targeted setups, the control plane will be running on a single node, and so then you go ahead and call it a master. But in more scalable, more mature setups, you're going to actually take those components that make up the Kubernetes control plane, and you're going to spread that out over a set of nodes, both for reliability but also for scalability. And so, comment in the chat saying that, like, yeah, in reality, when you're building a large production cluster, you're going to want to go ahead and take the core database for Kubernetes, and you're going to want to put that on its own set of machines. That's where essentially all the long-term persistent state for the Kubernetes system itself sits. And then everything else sort of like really centers around that database and the API server, which is sort of a policy server that sits in front of the database. Okay, let's see. Are we... Oh, is it up? Wait, it just like disappeared. I'm confused. Oh, there we go. Okay, sweet. Okay, so we're created. Yay! Okay, so what we're going to do now is, if you look at the outputs from the CloudFormation stack, there's this command line here for copying down your kube config. And so the kube config is all the information that you need to be able to access this cluster. So the first thing we're going to want to do here is, I'm going to clear this and... all right, so if y'all can't see this, let me know and I can maybe make the font a little bit bigger. But what we're going to do here is we're going to do SSH key equals that key that I created before, that I used before. This is ID RSA, right? And then you copy and paste this command line. And this is essentially says first SSH into that bastion host. And then from the bastion, go ahead and SSH into the master and copy out this thing called kube config. And so am I in the right? So where, okay, so I have, this is, okay, let me, demo, and I'm going to put it here in this demo directory. Okay. So go ahead and do that, and it's going to say, hey, you don't know these hosts, and you say yes to this because everybody always says yes to this. Now, I'm not going to cat this because it's going to actually have some private information that I don't want to broadcast. But what we can do now is we can actually go through. I'm going to copy a command line here. Don't ignore my... And so what this is saying, I'm going to set an environment variable saying this is where I want to actually find this particular thing. And there we go. And now I can do kube control get nodes. And if all goes well, we can see that we have our nodes. We actually have our master and 3 worker nodes that make up of our cluster. So you can use this command line, this environment variable, to find the kube config. The default place for it is is in your home directory kube config there. It turns out that there's, like, this is a whole nother topic, but there is a lot of structure inside of that. It's actually kind of a little bit of a database itself, and there's all these things that you can do to change context and sort of import stuff. Most of the time, though, people treat it as an opaque blob, and they copy these things around. And so that's essentially what we're doing, is we're actually viewing this file as sort of everything that I need to be able to get to my cluster. I'm going to store that, and I can actually point to different one of those when I actually want to talk to different clusters. We have some interesting ideas on what we can do to actually make this stuff be easier for folks to deal with. But for now, let's just go ahead and just use the file for doing this. Oh, so there's a question in the chat from Steve-O that says, what's the bottleneck for up to 2,000 worker node limit? It turns out you can go to like 5,000 worker nodes is what we've been testing, scale testing Kubernetes to. The biggest thing there is etcd and the scalability of etcd. Etcd is a quorum-based database, which is highly consistent, but that comes with a certain amount of coordination between nodes. And the good thing is it doesn't lose data. Once you put something into a system like that and it says that it's got it, it really has got it. The good thing also is that if one of the nodes falls down, generally the others are ready to pick up right away, and so it's really about consistency above all else. The CoreOS folks have been a great partner in terms of pushing the limits and improving etcd. etcd 3 is actually a heck of a lot more scalable. But as you start running larger and larger clusters with a lot more load on it, that's where you're actually going to go ahead and hit the limit. And I think there's a it's not as clear as like the number of nodes. It's really how big are those nodes? How much activity do you have? How many pods do you have? And so if you actually are interested, if you go, let me go to a different window, Kubernetes. So if you go to github.com/Kubernetes/community, this is the community repo, and I think in this there's sig scale. If I sig scalability, and there's a doc in here called goals. And so this actually goes through, the metrics and sort of the SLAs that we're actually trying to hit with Kubernetes. And so we look at like number of cores, number of pods per core. And so there's a bunch of assumptions. And this is how you actually get up to this sort of like 5,000 machine goal here and what that really means. And then the idea is that when you're running a completely loaded cluster like this, is the control plane still responsive? Can you actually still make work for it? So it's not like if you go to 5,001 nodes, the whole thing falls over. It's more like if you go past that, then things start to slow down, and you're not going to actually have the thing be as responsive as you really want it to be. All right, so that is a little bit of a digression there. Okay, so all right, so here we have a cluster. We're up and running. I can do kube control get nodes. Now I'm going to go back. So this is here. You all can see this. You can sort of like play along at home and actually see where we're going to go. Now the other thing I want to show you here is if I do kube control get pods namespace equals kube system, you can see that there's a whole bunch of stuff running here. And what you can actually see is that this is a lot of the Kubernetes control plane that's being managed with Kubernetes itself. And so this is one of those interesting things that over time we're working to make Kubernetes be more and more and more self-managing. And so I think this is really interesting. It's interesting to see this. So in some ways, this is like when you're on a Linux machine and you do PS and you see all these sort of processes and you're wondering, hey, what does that do? And those are actually there for managing the machine itself. Well, these are essentially processes that are running on Kubernetes for managing the Kubernetes cluster itself. Some of these things are run in a sort of more static, more limited way, and some of them are really scheduled like any other workload that you might be running on Kubernetes. All right, So the next thing we're going to do here is I'm going to go through and I'm going to run a single pod. So let's dissect this command line here a little bit. So kube control run, and I'm going to say generator is run pod v1. That's a little bit of noise. I'm doing this so that a lot of the stuff that we'll be doing later is simpler. So this is saying I just want to run a pod. I don't want to run anything else. Just make it be a pod. It's probably not the right default, and so that's why there's that command line, but it's a good default for demoing stuff, so let's ignore that. And then the image we're running here is this thing that I wrote a little while ago called QARD. And so this stands for Kubernetes Up and Running Demo, or daemon. So it's a book that I'm writing with Brendan Burns and Kelsey Hightower called Kubernetes Up and Running. It'll be out in a little bit, but we needed a good demo server for demonstrating some of the stuff going on there, and so I created one, and that's what we're going to actually play with here. And so yeah, so now I can go through kube control get pods, and I can go ahead and see, look, there's QARD. So it's up and running. Okay. So the next question here is, what the hell's a pod? And so that's a really good question. I think a lot of folks maybe tuning in already know what a pod is, but I'm gonna go into a little bit of detail anyways. A pod, for most users, a pod equals a container. It's essentially, I want to go ahead and run this container out there. But there are some limited cases, and we're seeing these things actually become more and more popular, where we want to actually run a lot of containers, or a set of containers that really work well as a unit. And so we really want to make sure that these things land on the same machine, and we really want to make sure that they have some level of trusted communication between them. And so when you take a group of containers that are really built to work well together, and you run those, that's what a pod is. And so a pod is the fundamental thing that Kubernetes worries about placing on machines. And inside of a pod, there's a set of containers, but it's really up to the user to actually figure out which containers run there. So concrete example of where you might want to run multiple containers in a pod. I think the most relevant one is a networking sidecar for something like Istio, which is very much on a lot of folks' mind right now, or other service mesh like Linkerd. Inside of Google, we would use a similar concept for, say, you're serving search, because that's kind of what Google does. You have a process that's actually like serving your search index. Okay, and it's actually going through and searching through a bunch of data and collecting things that match, and then running a ranking algorithm to go ahead and rank these things and only returning the top 10 results, say. Okay, that's the primary job of a search index. But we also want to refresh that index, so maybe we want to swap in new data. So what you can do is you can run a serving container, and then right next to that you can run a data loading container, and these two can maybe coordinate with each other using a disk volume or maybe a shared memory segment. And so now you can go ahead and have the data loader do its thing, drop the new data on, and then have the search index pick that up when it's convenient for the search index to go ahead and do that. And so now you have these two things that work well together, but they're logically two separate processes, but it's important that they actually land on the same machine so that they can coordinate with each other. And then over time, it's not quite there yet, you'll be able to actually give different priorities to different containers inside of a pod. And so you can say, hey, look, if the thing that's doing the search and the indexing, I really, really want to have that thing get priority. And if the data loading slows down or takes a pause for 2 seconds, who cares? Because that's actually not user facing. And so as we start looking towards more advanced scenarios like that, that's why we really created a concept like the pod. Okay, so somebody's asking, can I come to the Heptio office and get a signed copy of the book when it comes out? You'll bring some Nintendo t-shirts. I assume, Tromala, I'm probably pronouncing your name wrong. Tromala, I assume that you work at Nintendo. Number one, I would love a Nintendo t-shirt, as long as it comes with a Switch. And I imagine that when the book comes out, we can definitely host some sort of get-together here at the Heptio offices and have folks come by. I think that'd be a lot of fun. All right, so we have a pod here running. What I want to do here is that what this is doing behind the scenes is that this is a really fancy curl. It really is. So what this is doing is it's going ahead and it's generating a document, essentially a text file, and then it's uploading that document to the server, right? And so this generator here is essentially a way to take a set of parameters like the image and the name and turn that into that document that I want to go ahead and upload to the server. So let's go ahead, and what we can do is we can say, what is that document that it's uploading to the server? So I can go through and I can actually run this again, but I'm going to go dry run output YAML. Okay. And here you can see that this is the document that kubectl run is creating and then uploading to the server. And it's saying, I want to create a pod. The name of the pod is quard, and it has one container called this thing here. That's the image. And we name the containers inside of the pod, because if you have multiple containers in a pod, you want to tell them apart. And that's pretty much it, right? And so a lot of times when you see people talk about all the YAML that gets uploaded to Kubernetes, that YAML is the Kubernetes API itself. And there's some helper functions like kubectl run here that actually help you to create that YAML in a really sort of simple way. But at some point, there's a limit to what those generators can do, and you're going to want to go ahead and work with this YAML directly, or use some other type of tool chain to be able to create and manage this YAML. So that's a different project that we're working on here at Heptio, this thing called ksonnet. I'm not going to go into a ton of time there, but that's something that we use to help wrangle this YAML. And so you can take this YAML here, and we can save this to a file, we can check it in, and then you can have multiple teams coordinate in terms of like what you want that YAML to look like. And so in that way, we move from sort of this imperative way of thinking about the world of run this thing right now to a declarative way of the world where I check this thing in, and now we have an agreed upon sort of like, here's what we want to go ahead and make work. Yeah, so Ruben in the chat actually put ksonnet there. Ruben, can you go ahead and put the link to ksonnet.heptio.com where you can actually learn a little bit more about that and play with the interactive sort of like ksonnet authoring thing. Okay, so now we have this thing up and running, and that's all great, but like I want to actually see what it's running. So I'm going to run this command called port forward, and this is essentially, oh, you can't link in the chat. Oh, I bet you, yeah, otherwise you get a lot of spam because it is YouTube. That makes a ton of sense. Okay, so we'll maybe like collect some links and put those in the description for the video after the fact. I'm going to post a recording of this. Okay, so kubectl port forward is logically like an SSH tunnel, right? You know, this thing is it's running in Amazon, you know, behind these firewalls inside this thing. I'm on my laptop. How the heck do I get from here to there? Well, port forward is a good way to go ahead and do that. And if I go through and if I go to localhost 80, was it 8080? Oh, look at that. So now we have quard. And so you can see what we do with quard is it's a good sort of like test bed for understanding what's going on. You can see the environment variables. You can start playing with these more advanced things like readiness probes and liveness probes. It has a little thing for doing like playing with batch, and then you can look at the file system. So it's a fun little like test thing. And this was also me learning JavaScript, because I haven't done like JavaScript development since I was on the IE team, like, I don't know, like 14 years ago. So quard is kind of a fun little test bed for being able to play with this stuff. And so you can see that we've gone from taking a container image, a Docker container image, and running that on Kubernetes, and then getting some limited access for sort of development playing with that particular pod. All right, and then I can go ahead and I can delete this thing. So I can Control-C out of that, I can delete it, and then this thing, if I try and do this, it's like I can't get to the server and it gets mad. So now I can do kubectl get pods, and there's nothing there, obviously. Now, pods are great because it's a way to say, here's what I want to run. Go ahead and find me a node to run that on and then run it. Okay? But there's a couple of things that pods don't do well. The first thing that they don't do well is that you have to manage pods one by one. And in any sort of production system that you'd want to use Kubernetes, it's so much common that you want to deal with a set of things than deal with singletons. Anytime you're dealing with singletons in production, you're kind of setting yourself up for pain. And so you'll see as we go through that fundamentally we built Kubernetes to deal with sets. So much of what we do with Kubernetes is dealing with arrays and sets of things versus individual things. The second thing that pods don't do is that once a pod lands on a node, it's on that node forever. So that means if that node disappears, if that node has a hardware problem, and if that node goes away, that pod dies with that node. Now, this seems very counterintuitive because we really want Kubernetes to work well in a dynamic, noisy, sort of like realistic production system where things actually fail. But the reality is that things do fail, but they fail in interesting, non-obvious ways. And so a common failure mode that we have here in real data centers would be something like a network split. And so the real question is, how do we know when a node is really dead? And if you get a network blip, or if maybe like the load is under a ton of load, and maybe the agent on the node is under a lot of stress and it can't respond to health checks, well, now all of a sudden the master components, this control plane, now thinks that node is dead. But maybe it's not really dead. Maybe it's like 5 minutes later, it's going to go ahead and come back, right? So if we were to actually go through and say, oh, that node's dead, let's take that exact same pod and run it someplace else, bad things happen when that other node comes back, because now we have 2 copies of that pod running on the system at the same time. And that actually ends up being really confusing when you're doing things like aggregated logging, right? Because you think like you're taking that pod name and you're using that as a key to actually collect your logs. Now we actually have logs coming from 2 different pods and 2 different machines with the same name. Like, oh, that's just pandemonium. Who knows what's going to happen? And so when a pod gets created, it gets, once it gets assigned to a node, it lives and dies with that node. But what we do is we have these systems that we build on top of Kubernetes to actually manage pods for you. And so the first one on top of it is this thing called a replica set, but then built on top of replica sets is this thing called deployments. And that's what we're going to go ahead and work with next. So here we're going to call kube control run again. But if I can actually select, damn. All right, we'll do it this way. Okay, kube control run again, and it's going to actually start this thing called a deployment instead of a pod. And here I don't have to specify the generator because this is actually the default, because this is what folks want most of the time. And I'm just going to specify the image, and I'm going to say I want 5 replicas. And this YAML gets a little bit more complicated, but essentially there's some part of it which is the number of replicas, and then there's this other thing called a template, which is essentially the cookie cutter that I'm going to use to stamp out the pods for this deployment. So this is going to say I want to run 5 QRDs, and I want to run this thing, and I want each of them to actually use this image. So let's go ahead and run this for real. And if I see the pods now, what you can see is that 3 of them are up, 2 more are actually go ahead and coming up. Now they're all up. And it creates a unique name per pod, right? So this is actually the name of the deployment. And then these end up, this is actually a hash of the template. And then this is a unique value for each pod in that template. And so in this way, that deployment object, and I can also go kube control get deployment. It'll show me that deployment there. I wanted 5. I currently have 5. They're all up to date and they're all available. Everything's looking good. We're 5 by 5, right? Now I can go through get pods. Okay. Now the interesting thing here is that port forward currently only sends you to a particular pod, and really the service is a whole bunch of things. So we want to find a way to actually, this deployment is a set of pods, right? And so we want to find a way to access that set of pods. And what does it mean to access the set of pod? It means put a load balancer in front of it, and every time a request comes in, steer it to one of those that makes sense. And so let's go ahead and do that. So we're going to do this thing here called kube control explodes the deployment. Amy's bringing me water. Thank you, Amy. I have beer though, Amy.
Someone said you needed water.
Oh, okay. Somebody said I needed water. Oh, and there's a question in the chat, is that will I be posting the notes that I'm working off of? Yeah, I'll go ahead and I'll find like a GitHub repo and I'll throw those up there someplace. Okay, so we're creating a deployment, and the deployment is called quard. We're exposing the quard deployment, and we're saying type equals load balancer, and I want the load balancer to map port 80 to port 8080, right? Because I'm running port 8080 inside of my container, and I want to map it to port 80 to the rest of the world. Let's go ahead and run this. And what this is actually going to do is a whole bunch of things. It's going to create this thing called a service. And a service actually can do a whole bunch of things depending on the options that you're actually giving it. So the first thing that a service does is it finds a way to essentially name a set of pods, right? And so we're using this concept of labels, and you'll see these sort of sprinkled throughout the YAML to say, hey, I want to point this service at the same pods that deployment is managing. Now, it turns out that service and deployment don't know about each other, but in this particular case, they're using the same sort of criteria to search for and find the pods that they're managing and that they're dealing with. All right, so I'm saying let's create a way to name those things, and then I want to go ahead and collect all those IP addresses, and then put an internal Kubernetes load balancer in front of these things. And so this is this system called cluster IPs. And so this makes it easy to access services from one Kubernetes pod to another through this service abstraction. But that only works within the cluster. So the next thing it's doing is it's saying, I want to now take this and I want to pick a port across the cluster and make it such that if you hit any node in the cluster on that port, then that gets forwarded to this service. And so that's the next thing that this does, and that's called a node port. And if we go kube control get service quard, and then we are going to go ahead and actually show that. Okay, so here's the node port. So the node port on this thing is 30,797. So it picks a random port, and if you hit any node in the cluster on that particular port, then it'll route to one of the pods that's actually matching that particular port. I mean, this particular service. So that's great. But remember, we're running in Amazon in a private VPC. I'm sitting here on my laptop. I can't hit any of my nodes directly. So the next thing that we do with service is, and this is what the type equals load balancer do, is it says, go ahead and create an ELB for me. And point the ELB at all of the nodes in my cluster at this particular port. And this is why I'm talking a lot, because ELBs are slow, and it takes them a while to actually spin up. So Kubernetes, the way that it's set up on Amazon, will go off and create an ELB and configure everything such that ELB targets this service that we're building. So I can go through and let's do a dig on that ELB. Okay, it's up and running. Now I can go through and instead of doing localhost, I'm actually going to hit this thing directly, and you can see that this actually goes through to quard. And if I reload this a couple of times, you'll see, and if I do a forced reload because of, you'll see that actually I'm getting different nodes at each time, right? So it's actually doing a load balance across these things. So at this point, ship it, we're done, right? Just create a CNAME for that thing and we're off and running. But I want to actually show a little bit more here. So the first thing I'm going to do here is I'm going to get fancy with my terminal. Let's see if I can remember how to do that. Okay, so we have 3 terminals here. So the next thing I'm going to do is I'm actually going to go through in the top window here is I'm going to do a watch, and we're going to watch the pods that we're running because we're going to do some updates here. And then the next thing I'm going to do is I'm going to I need my kube control. Where is it? There we go. I want this thing. I'm going to go ahead and I'm going to run a loop down here that is, what did I do? Invalid. So maybe I gotta do that. There we go. All right, so now what's happening here is I'm hitting one of the API endpoints on quard. I'm extracting out a value, which is the host name of this thing, and I'm printing that out in a loop. And And so, as I do that, you can see that it's being load balanced, number one, across a whole bunch of different nodes, and number two, that I'm not seeing any errors. So that's good. Okay. And then the other thing is that you can see that the middle value here, which actually is a hash of the template of the pod that I'm using, that middle value is not changing as we go ahead and do this stuff. So the next step that I'm going to do here is I'm going to go through and I'm going to start playing with this deployment. So the first thing I can do is I'm going to actually scale the deployment up. Oh, you know what? What I screwed up is I didn't do the export kubeconfig equals kubeconfig cdemo. There we go. Okay. And you can see immediately it brings these things up. They're up and running. It's actually really fast. It's pretty cool. The QRD container is really small. It's a Go binary that's minimally packaged, so it comes up super quick. Now, what this is doing behind the scenes is it's logically downloading the current version of the deployment resource, editing it, and then posting that back. And there's all sorts of versions for optimistic concurrency. So there's this fun command called kubectl edit. Different QRD, which essentially lets me do that manually. So I can go ahead and do that, and it brings up my editor. And you can see here's what this thing looks like. And if you look at this resource, the way we break it down is there's all sorts of metadata about the resource. There's the and this applies to pretty much every resource, has similar stuff like this. There's a specification. This is the stuff that we upload. It's been filled in with a bunch of defaults. And then there's the status. What is the current status of what's going on? So this is like the available replicas, that type of stuff. And so what we're going to do here is we're going to actually change this back to 5. I'm going to save this, close the editor. It'll post this back, and it'll go ahead and terminate and kill these. So when you want to scale your deployment, you can do the imperative thing here, like kubectl scale. Or if you want to be sort of really formal about it, you can go through and you can edit your checked in YAML and then use that to essentially adjust your scale in terms of the number of instances that you're running. All right, so the next thing we're going to do here is that we're going to change the image. So changing the scale means that the ones that are currently running keep running. But what if I change to QRD version 2? Right, let's go ahead and do that. So here I'm using this thing called set image on the deployment, but this is doing something very similar to what we did before. It's downloading the resource, editing it, and then uploading the new version. So let's go ahead and execute that. And as we see that, what you can see is that the deployment object is making it so that we do a rolling update of both the old version and the new version together. And if you'll notice on the left here, I forgot to watch, it didn't miss a beat, right? We didn't get any errors, and it updated to the new versions. We can tell by the new middle value here on this thing. And so we just did a rolling update to a new version without dropping any connections with Kubernetes. So that's pretty cool. And then let's go ahead and we can scale up again. And then as we do that, let's go to version 3. So we're both scaling and upgrading at the same time. And it turns out that it just works, right? The way that Kubernetes works is it's declarative. You tell it what you want the system to be, and it doesn't matter generally what order you make things happen in. It'll actually figure out, and then let's do, and then we can do this other thing here where we can do a rollback. So let's go back to version 2, and then while we're doing that, let's go to 20, and it's automatically figuring out how to make all this work. And let's see, and so this is actually rolling this stuff out very quickly. If you have an app that takes a while to launch, if it takes a while to warm up, there's these mechanisms called probes that can help you to have the application communicate with the Kubernetes system so that you can do graceful shutdowns and you can warm up. And if one of your servers is sick, there's a way for Kubernetes to detect that and automatically go ahead and restart it. All right, working my way down my script here. Okay, so how are we doing on time? We're going to run out of time here. Okay, so the next thing I'm going to do, we're going to do something a little bit funky here. We're going to install WordPress. Actually, you know what? Let's save that for a different time because I think we can do, this is using this thing called Helm, which is really fun. but we're not there yet. So let's go ahead and leave that off for now. What I do want to do is I do want to go through and number one, if you have any more questions, go ahead and ask me. But I want to go through and look at the 1.7 release notes and talk a little bit about sort of what's happening in 1.7. That's the feature. Here's the change log. Okay. So there's a lot of stuff that goes into a Kubernetes release. The biggest thing that, and if you guys want to steer me in a certain direction, go ahead and let me know. The biggest thing that we've done with 1.7 is we have continued to enhance extension points. And so our real goal over time with Kubernetes is to get to the point where the kernel of the system, the nucleus of the system really doesn't need to be changed. And all the innovation, all the exciting stuff is happening outside of that nucleus. We really want to get to the point where without checking into the main code base, you can do really interesting things. And what this really means is taking Kubernetes, which is already pretty extensible and pretty well componentized, and breaking it up even further, right? So instead of having one single version with one single master, we want to have ways to create APIs, have those things plug themselves together, and then build on each other. And so there's been a lot of work going on around that. It's not super exciting work. It's not really sexy, but we think over the long term, it's gonna be the thing that really lets Kubernetes scale as a community and lets it really sort of work in all sorts of different situations that we didn't necessarily foresee when we were first making the system. So extensibility was definitely a theme, and it's going to be an ongoing theme. And then the other one is security. When we first built out Kubernetes, a lot of our focus was on getting those core primitives right. And we're now starting, we think we've hit the right notes there. And so we're starting to fill in a lot of the gaps in terms of making it not work just for a single team or a single application, but having it work in a more scalable way across a bunch of teams, say at a big company. And as you start working sort of across a lot of different components, a lot of different applications and a lot of different teams, you want to find ways to isolate those teams from each other. And from a security point of view, if something bad happens and one of your workers on your cluster gets compromised, we want to limit that damage and make sure that the attacker can't spider out from there and get to other parts of Kubernetes. And so those were the two themes. Now there's also some interesting work going on with network policy and stateful applications. Some of this stuff is in alpha, some of this stuff is in beta. I'm not the expert on all of this stuff because it turns out that Kubernetes is a big enough project now that I don't think anybody is the expert on all of it. It's a full-time job just to keep up with all the stuff that's going on. So let's go ahead. So the first thing is that there's some notes in terms of actions required before upgrading. Most of these, as you actually look through it, they're going to be relatively isolated to things that are in the alpha stages. So we take very seriously inside of Kubernetes backward compatibility. When something is GA, we don't want to break folks, right? Now, if you see something marked with an alpha label, there's a good chance that you're going to have to adapt as new versions come out. If it has a beta label, we're going to try and make sure that it's right, but there still may be some changes. If it has a release or a GA label on it, then you can be sure that people are going to work very hard to make sure that there's compatibility from one version to the next. So here's like the network policy here. It's been moved from a beta to a V1. So this is a promotion to a full API. But mostly the structure has been unchanged. And so it's mostly a naming change to actually reflect the fact that this is now a stable API. Things like, there's some alpha features that have been removed. There's some, different sort of integrations with different with different providers that maybe there's some changes there. See, API machinery is what we use to talk about the core way that APIs sort of users interact with the system and all the components actually work together. There's been a lot of work to take this and break it out and make it more generic and more federatable across a bunch of different bunch of different contexts. Yeah, so a lot of good stuff going on here. Some known issues, some deprecations. But let's go ahead and talk the features. So there's federation. KubeFed is a tool for dealing with federation. Let's see, I think. Okay, so the Kubernetes API. So we had this thing called Beta, which was called third-party resources, which is one of the extensibility mechanisms. It was incredibly interesting to actually see what folks were able to do with this. But there were some things with third-party resources, like the name, that I think confused folks and that we weren't super happy with. And so third-party resources are now deprecated and they're being replaced with this thing called CRDs, or custom resource definitions. And so you can go ahead, there's a migration guide here that actually talks about the differences in how you can actually move from one to the next. But again, this is one of those cases, oh shoot, I lost my place, where this is one of those cases where it's a beta feature that we learned a lot through the beta process and some changes were made as we move forward. Okay, so we have this thing called API server aggregation. So this is an idea that there's really two ways to extend the API surface area of Kubernetes. There's these custom resource definitions, which are relatively easy to get started with, but they don't provide a lot of features in terms of validation. And so they can lead to maybe a somewhat less than ideal experience for end users. Or you can go ahead and essentially build a whole nother API server and then use some of the API machinery for Kubernetes, things like authentication and authorization, and then have that forward to your API server. And so those are called aggregated API servers, and those things are making it to beta. And the main API server for Kubernetes can both service its own resources, but then act as a forwarder to these aggregated API servers. And then there's this really exciting thing here called this is like admission controller. So admission controllers are this idea that anytime you talk to Kubernetes, there's a whole set of code that runs to validate that the resource, that YAML that we're giving to Kubernetes is valid and that it meets some sort of policy that you might want to define. And so it's called admission because you're actually putting sort of a bouncer at the door to actually let changes into the system. And for the longest time, this stuff was really was compiled into the API server, and the configurations for these things with command line flags. And so what that meant is that if you were using something like Container Engine, it was really difficult to go ahead and configure these things. But with extensibility work that's going on, we're moving to not only making these things work via a webhook, so that means that you can actually run these admission controllers when they're not part of the Kubernetes process directly, but this is essentially an API for registering these things and managing them themselves. And so this means that as this makes its way from alpha to beta to general release, you'll be able to actually launch a Kubernetes cluster with things like Google Compute Engine, Container Engine, and you'll be able to actually modify the policy and essentially some of the core ways that the control plane works. And so that's going to be a really interesting opportunity to do a lot of interesting stuff with Kubernetes. Okay, so let's go through stateful sets. So stateful sets are a way to essentially have these deployments like I showed, but back those things with some data. And so you want to be more deliberate about how you actually grow and shrink and address these things. And so stateful sets are essentially a way of thinking about deployments, but for things that have a whole bunch of concerns around making sure that they work well with attaching volumes. We didn't go into volumes at all through that quick demo. And so now these things support, being able to do rolling updates and essentially a lot more of the behavior that you'll get with the deployment also apply here. Daemon sets also supporting upgrading and rollback, which I think is really critical. So a daemon set, so like you saw here, we said run 10 QRDs, but there's cases where you want to say, I want to run a container, but I want to run one of these containers on every node, or I want to run one of these containers on every node in this zone, or some subset of my nodes. And so a daemon set is a way to say run a container on every machine versus I want to run 10 of these things. Most of the time, end users, if you're using a cluster, you're not going to want to think about and use daemon sets because you really shouldn't have to care about machines. Like Kubernetes is all about pods and such and containers, but when you're managing the system and you're actually trying to install, say, like a log aggregator that actually aggregates logs across all containers, that's where things like daemon sets become useful. Let's see. I'm running out of time here. Extensible admission control. So I talked about that. TLS bootstrapping. Right now, when the parts of Kubernetes stitch themselves together, they now support automatic rotation of these things. So that's really cool. Let's see, some audit logging, encryption at rest with secrets, and then a big one here is this thing called the node authorizer. In the previous version of Kubernetes, as the individual agents running on the nodes talk to the control plane, they had access to a lot more information than they needed to do their job. What this node authorizer does is it actually makes sure that nodes only get access to the information that they need to do their job. And so it's one of these things that sort of limits the blast radius if a particular node or if a container on a node were compromised. A lot of fun stuff here around cluster lifecycle and scaling, auto scaling, command line features. I think we're going to run out of time. Networking, network policy, and load balancing. This is really interesting stuff too. We're out of time. Okay, the one last feature I do want to call in. This is in alpha, but this is this feature called local storage. And this is really cool because storage in containers is really difficult. The default way for dealing with data that you care about in Kubernetes is using Kubernetes on a cloud like Amazon or Google or Azure, and using the built-in remote block store. Okay, so yeah, so Ruben's saying thanks. So I'm going to finish up here. I think Ruben's trying to hurry me along. It's use a remote block store and attach that to nodes as the workload. So like the workload lands on a node and then we'll like attach the volume to that thing. This is a way where we can actually say, well, allocate me some space on one of the nodes and let me use that. But I don't want to have arbitrary access to data on the node. And if I need to get restarted, I can actually reclaim that space. And so that ends up being a really interesting thing to do. And that lets you do things like, say, allocate a node with a local SSD and then attach, schedule some Cassandra servers on that thing and have that thing automatically use the SSD. And if you need to reboot everything, it can actually find the data that it had before. All right, so I'm going to wrap up. I think I'm out of time. If all y'all have questions, comments, please drop us a line. Let us know. Hit us up on Twitter or in the comments here. We're going to go ahead and we will publish this video. We're going to put some of the links in the notes there, and then I'm going to go ahead and take that demo script that I had and throw that up someplace, maybe in a gist, and link it from the description. If you could please subscribe to the channel, because if we get 50 people subscribed, then we it unlocks some features and we actually get to give it a real name and stuff. So if you can go ahead and do that, I'd really appreciate it. And let us know what you think, and we'll try and make this be a regular thing. So thanks for watching. I really appreciate it.